In this example, we are being given the initial position of a particle, and then we are being given the velocity equation for that particle at any moment in time. And they want to know after t equals 4, after 4 time units, what is the final position of this object. So this again gets back to our physics relationship that they really beat on in these AP physics classes and really want you to know. So if your original function is the position function, then the first derivative of position is equal to the velocity function. Normally we do a lot of going down this little ladder here, starting at a position and going back, or taking the derivative to get the velocity. This time, however, we're going to be taking an antiderivative. We want to go back up from there. And what we're going to need to know is that when we take the antiderivative of our velocity equation from some A to some B, that what this is going to give us out is this is going to give us the total displacement over whatever that A to B is, over whatever that time amount is from A to B right there. And that's really what we're looking to do here. So what we've got is we've got a starting position of 5 essentially. And what we want to know is, if we think about it, like, where do we end up over here? And so to do that on this problem, we're just going to need to find the antiderivative of our velocity equation that they gave us. So this would be the cube root of 3 plus t squared dt. And then they want to know over the first 4 time units. So what we'd be doing here is we'd be saying starting at 0 and ending at 4. Looking at that, initially you're like, oh man, how am I ever going to find the antiderivative of that? That looks pretty complicated, maybe a U substitution. But the glory of this problem is the fact that it is on the calculator required section. So to do this problem, we're actually going to be done pretty quick by just using the calculator. What we're going to do to get that antiderivative value is in y1 on my calculator, I'm going to put that equation that they're giving me. So the cube root of 3 plus t squared. From there, I go ahead and then graph that. So step 1, put the equation in. Step 2, you would graph it. And now step 3, we would go ahead and hit the second, calc. And then inside that calc menu, we're going to choose the number 7 option, which is the integral of f of x dx. It's then going to ask us a couple of questions for the lower and the upper limit. And what we'll get out of there is our total displacement. So from our starting position, where did we end up? How far away did we end up? So let's open up our calculator and get this thing done. So we pull up the calculator. You're going to go into your y equals now, the button in the top left, and you're going to enter that equation, just how it looks. So we want a cube root. The cube root button is under the math button on the left-hand side there. And then if you scroll down to that number 4 option, cube root, and hit enter on that, that's going to give you your cube root. Then we'll do 3 plus, and whenever we're graphing, instead of t's, we're always going to type them in as x's. So this would be x squared. So we put in our equation. We hit graph on that, and now we're going to go calculate that antiderivative value. So we hit second, and then the calc menu, the button above trace at the very top here, and you're going to scroll down to the number 7 option in that menu, the integral of f of x dx. You'll hit enter on that, and now it's going to ask us a series of questions. The first thing it wants to know is the lower limit. Well, that's another way of just saying the lower bound. So our lower bound on this one is 0, so I type in 0. Hit enter, and then it wants to know the upper limit or the upper bound. Well, the upper bound of our integral was 4 in this situation. So I type in 4 and hit enter. And it shades it all in, but then the more important part is at the bottom of the screen there, you can see that it says the integral of f of x dx equals 7.8138. On a AP Calc test, we kind of always want to round to 3 decimals, so 7.814. So our total displacement over that 4 second or that 4 time unit interval right there is 7.84. We can't forget though that our starting position was already 5. So we're going to go 5 and then we're going to add another 7.814 to that. And that's going to tell us that in the end of this thing, we're going to end up at 12.814. So our final position is 12.814. which would be option C. So a scary looking antiderivative, not that bad when we've got our calculator to do that heavy lifting for us, and then we just use our physics knowledge to put this all together. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.